What is life? Why is life here? Is life on Earth one of a kind? Or does it have a larger and yet undiscovered family? People just like you and me have wondered about this for thousands of years, which compelled us to look beyond our own neighborhood, the solar system. Our solar system is so huge and consists of so many objects: big, small, rocky, airless, gaseous, hot, cold, and more. Now think about it. There are 100,000 million stars in our galaxy only. So, isn't it a bit hard to believe that our sun is the only star that's been able to pull this trick off? Well, what if I tell you that our solar system is not alone at all, and that there are planets around almost all the stars you see at night? Officially, we call them exoplanets or extrasolar planets. An exoplanet is a planet that is found outside our solar system and usually orbits a star. Now you might ask, do all exoplanets look like our solar system planets? Well, not at all. We have rocky planets, which are bigger than Earth but smaller than Neptune, and we call them the super-Earths. Then there are gas giants like Jupiter or Neptune, orbiting so close to their stars that their temperatures soar into thousands of degrees. So we call these the hot Jupiters or hot Neptunes. On the other hand, some are the size of Jupiter or Neptune but are really far away from their stars, and we call these the cold Jupiters or cold Neptunes. You get the idea. There are also the rogue planets that don't really orbit any star and wander the galaxy all alone. But also, there are planets that orbit 2, 3, or even more stars. For the Star Wars fans, yes, just like Tatooine. There could be terrestrial planets, egg-shaped planets, desert planets, ocean worlds, ice giants, lava planets. I'll run out of fingers, but the list will go on. Now the question is, how do scientists even find them? Can we look for them on Google Maps? No. Can we see them in the night sky just like the stars? Well, exoplanets are too faint to see with just your eyes. Astronomers have devised several clever methods of detecting exoplanets. One is, we can directly look for them through these crazy advanced telescopes, which is known as the direct imaging method. By July 2021, scientists have found 53 exoplanets using this method. Unfortunately, direct imaging of exoplanets is extremely difficult and in most of the cases, impossible. But why is it so hard? It is because the stars are so much brighter than the planets, and from such a distance, it makes the planet barely visible on Earth. So what do scientists do then? Let's see. Remember when you were a kid, you used to hold hands with your friend and spin in a circle? That is what exoplanets do with their stars. The star moves, even though a little, in a small circle or ellipse, responding to the gravitational pull of its planet. So as the star moves towards you, the light appears bluer, and if it moves away from you, it appears redder. This is the radial velocity method, and it helps scientists detect not only the exoplanets, but also their mass. But the most popular method for detecting exoplanets is called the transit method. The transit method is the most popular because it is the most effective. It has allowed scientists to detect more exoplanets than radial velocity and direct imaging combined. So how does this transit method work? When a planet orbits a star, it might pass in front of the star and block a little bit of its light. This dimming tells us that an exoplanet is orbiting the star. Plus, scientists can use the transit method to measure the size, orbit, and temperature. And along with the technique called spectroscopy, they can even find out the gases present in the atmosphere of the exoplanet. Now the question on everyone's mind is, do exoplanets have life on them? And how would we know? One clue is if the exoplanet is in the star's habitable zone. But what is the habitable zone? Well, we can safely say that water makes life possible, at least on Earth. and we know that Earth has life on it. So a star system's habitable zone is the region around it where a planet-sized body could maintain liquid water, provided the body has a surface and the right amount of atmospheric pressure. So, not too hot where it gases off or too cold where it becomes ice. In a sense, it is just right. So this habitable zone is actually the starting point to understand our place in the cosmos. But whether we find life or not, that really depends on what is out there. Does water mean life, like us? Or is it something we haven't even imagined yet? Can life even exist on these weird and mysterious planets? What if extraterrestrial life is too alien to be recognized as alive? With the upcoming James Webb Telescope, a space telescope that is developed by NASA, ESA and CSA, we may be able to get closer to these distant worlds and get much clearer data. Who knows what we might discover?